Hello, welcome back to the Pre-Calculus Podcast. I am your host, and this is episode 11.5, Permutations. This episode does not have a sponsor because of the previous episode's incident, episode 11.4, which we shall not discuss ever again. So, this new episode is about permutations! Yes, that's what we're talking about, is permutations. So today we're talking about permutations and how we can use them in mathematics. So the first thing is, let's say we have an example like this. We have the letters A, B, C, and D. And what we want to do is we want to put them in order randomly and see how many different orders can be done. So how about you take a minute, pause this video, and see how many different ways you can organize these letters. I can wait. Now, hopefully, when you start listening about, so you've got like A, B, C, D, A, B, D, C, A, C, B, D, A, C, D, B, B, D, so on and so forth. You end up with 24 different ways that you can list them. Okay? So you end up with 24 different ways that you'd be able to organize these letters. Okay. Now, if, let's say we, instead of having it with just 4, what if we wanted to do the entire alphabet? Now, see, that's where it becomes difficult. And we don't want to just try to do it by ourselves. So, that's why we have something called a permutation. Okay. And so what a permutation is it's taking two numbers, a total number and how many you want from the total. So if you want a subgroup of a larger group. Okay. And what a permutation does is it takes all possible orders of a group. So if I had, let's say, the A, B, C, D, okay, there's 4 numbers and I want groups of 4. How many ways can I order that? So the order matters in a permutation. I picked A first, then B, then C, then D. That group is different than if I picked D first, then C, then B, then A. And that group's different than if I picked D, then C, then A, then B. Okay, so all those are different because they are different order. Order matters when you deal with a permutation. Okay, so the order is key. Now, what's basically happening here is when you have, let's say, A, B, C, and D. So A, B, C, and D. What ends up happening is that we have how many numbers can go into the first slot. You can have 4 numbers go into the first slot. Okay. Now, after you fill in that first slot, how many numbers can go in the second slot? Well, if we put A in there, we only have 3 letters left. So we have 3. How many can go into the next spot now after you filled the first 2? You can only have 2. And then how many can go into the last spot? 1. Okay. What you end up doing is you end up multiplying those together. So you multiply all those numbers together, and that's how we get our 24. And so what a permutation is, if you take a permutation of an entire group, you end up doing what's called a factorial, which is this little exclamation point. And what that means is that whatever the number is, you multiply every number lower than it, going from the beginning to the end. So if you start with 6, it'd be 6 times 5 times 4 times 3 times 2 times 1. If it's 100, it'd be 100 times 99 times 98, 97, 96, 95, 94, 93, 92, all the way down to 1. Okay, so that's how these work, and that's what a permutation would be if you take the entire group. Okay. So now, what if we have 9 factorial, but we want to write it, so instead of it's 9 factorial, we want to write it as something with a 6 factorial in it because of reasons. Is there really a reason why we do it? No, but we just want to see what we can do. Well, 9 factorial can be written out as 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay? So we can write it all out and we're multiplying all those. Well, if we want to write a 6 factorial, what is 6 factorial? 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. So we could end up writing this as 9 times 8 times 7 times 6 factorial. Now, how this can be helpful is that if we wanted to reduce. If I had 6 factorial and I wanted to reduce, or 9 factorial and I want to reduce it from 6 factorial, what I can do is I can rewrite the top as 9, 8, 7, 6 factorial all over 6 factorial. And as you see, those 6 factorials cancel out, making life so much easier. Okay, So now let's say we have our next one. We have 15 factorial, and we want to write it as 10 factorial. Well, how do we do that? Well, we'd write it as 15 times 14 times 13 times 12, 11, and then the 10 factorial. You see, life is simple when you do math. It's always easy. Okay, so that's just different ways of you can writing a factorial into different things. Now, let's say I have 15 books on my shelves. How many ways can I organize these 15 books? Well, think about it how we've talked about with the letters. How many books can go in the first spot? That would be 15 of them. Okay. How many books can go in the second spot? Well, I've already used one, so that means I'm down to 14. How many can go into the third spot? It'd go down to 13, and then 12, 11, 10, 9, and all the way down to 1. So that is the same as 15 factorial. So 15 factorial, which you see is a massive number of 1.31 times 10 to the 12th. Okay, it's a huge number. And that's what happens when we deal with factorials. They grow extremely quickly. Okay, they grow very, very fast. And so we just have to watch out for those. Okay. Now, only 9 of my books can fit on my shelf. So my question now is, how can we find how many? Okay. Well, if I have 15 books and I only have 9 spots, well, we still start at the beginning. First spot can hold 15 books. Next spot can hold 14 books. Next spot can hold 13, and then 12, and then 11, and then 10, and then 9, and then 8. We're at 1, 2, 3, 4, 5, 6, 7, 8, and then 7. So we have our 9 spots there. So how can we have a formula that we would get this, in which we would multiply all those together? And what that is it's using a permutation. Okay, 15p9, the first number is the grand total, 9, or the second number, is how many you want from that subgroup. And as you see, we have 1,816,214,400. All right, so back from a short little break, and now we have our permutation. So whenever we want only a few from the whole set, or only a subset from the entire set, we're going to use NPK, or NPR, depends on how you want to do your last number. And what you're going to do is you're going to go n factorial, so the bigger number factorial, divided by n minus k factorial. So in the previous example with the 15 and 9, what we would end up having is we'd have 15 factorial all over 15 minus 9 factorial, okay, which would put us at 15 factorial over 6 factorial. And so what we'd be doing is that we're dividing out 6 factorial from 15 factorial, which gives us 15, 14, 13, 12, 11, 10, 9, 8, 7. Okay, and you see we have that number. So take a second and find the permutation for each of the following, 12p5 and 25p20. Okay, so I'll give you a second. Okay, now, if you're smart and you use your calculator, okay, your calculator can do this. If you just push the math button on your calculator, and then you arrow over to PRB, and using a TI-8384, not sponsoring this episode, you can see number 2 is NPR, which is the same thing. It's a permutation. Okay, so 12p5 would end up getting us all the way down to 95,400. Okay. And then 25p20 ends up getting us a very large number because it's 25 factorial over 5 factorial, which is 1.29 times 10 to the 23rd. Okay, so it's a very, very large number. Okay, so now let's talk about non-distinguishable objects. So these are objects that look the same. Okay, so these could be letters, these could be balls, these could be anything else that looks similar to each other. Okay, and you're unable to tell the difference between one or the other. So if you look here, we've got orange and red and green circles. There's no way to tell them apart. They are exactly the same. And so what we want to know is we want to know how many ways can we put these in a row. Okay, as you see, there are 5 red, 3 orange, and 2 green. Okay, so we have all those, and we want to find how many ways we can put them in a row. Now, we can't just use 10 factorial because some of the numbers repeat. If I do all the reds first and then all the orange and then all the green, how am I going to tell which red is red? Which red I put first compared to which red I put second? Okay, so we don't know what the order is. So what we have to use a slightly different formula to deal with these non-distinguishable objects. And that formula is as follows, which is n factorial all over r1 factorial times r2 factorial times r3 factorial times r4. So the n factorial is your total number of objects. I had 10 circles. Okay, I had 10 circles. That goes on top, 10 factorial. Underneath that, I put how many, every repetition, and you take that factorial of how many they repeat. I had 5 red, so I have 5 factorial on the bottom, along with 3 factorial for the orange, and also the 2 factorial from the green. So, as we see here, I've already kind of told you what it was, no surprise. So we have all our numbers, and if we look right here, you can see, you can count again. You have 5 red, 2 orange, and 2 green, or 3 orange and 2 green. So we plug in our numbers here. So we have 10 factorial over 2 factorial times 3 factorial times 5 factorial, and then we just simplify, multiply it through. You can try to reduce stuff from it. That's fine as well. But we end up, so I broke it up like this, which, as you can see, the 5 factorials cancel. 2 and 3 and the 6 can cancel, and then I'm going to reduce this to a 4 and this to a 1. So now you see I have 10 times 9 times 4 times 7, and that's going to end up being my number, if I can put it up. So that means that I could actually organize those only 2,520 different ways instead of the 10 factorial total number of ways that I could have done it. So you see it's a lot less because we have those non-distinguishable points. Okay, so now we can take this and we can apply it to words and names. So let's say we have the name Tallahassee. Okay, so if I wanted to see how many ways I can organize the letters of Tallahassee, first we have to count how many letters there are total, and then you want to count the repeats. So in this case, we have 11 total letters. T appears once, A appears 3 times, L appears twice, H once, S twice, E twice. And I put all those underneath, and then I can start trying to reduce it. And as I start to reduce it, you see I get a grand total of 831,600 different ways I could spell the letters Tallahassee. Okay. All right, so that is our thing about permutations. Okay. Here's your homework, and hope you were able to understand what this section was. I hope you have a great rest of your day, and all that stuff.